Thank you, everyone. My name is Christopher Daly, and I'm here with Sruthi Anumula, and we're here to talk about Vertica beyond the bare metal. So let's start where it all began. Back in the old days of version 1, version 2. When Vertica was initially designed, the idea was to create a shared nothing cluster model that could run on inexpensive commodity or generic hardware. And those choices in design represented an architecture that was not only simple, but also fairly robust, while also being extremely performant. Of course, that design has been tweaked over the years with the addition of new features, while streamlining some of the old functionality. But running Vertica on bare metal is still considered the optimal choice for performance. In fact, the majority of our current install base today still runs Vertica on bare metal, utilizing what is now referred to as the enterprise mode. Why? Because Vertica will always perform best on bare metal. When you run Vertica on bare metal, there's less overhead on the server hardware, as the OS has direct access to the hardware layer. Additionally, typically the hardware deployed has been purposely purchased for the solution, and more likely than not, the bill of materials has been specifically chosen to support Vertica. Finally, because the hardware is only deployed to run Vertica, it can be tuned at the hardware layer to support high-performance, low-latency applications. There used to be a time when we would produce a bill of materials for specific hardware vendors to build a Vertica cluster. But with the number of hardware vendors that customers are now using, we've had to adjust our approach a little. The QR code on the right links to our generic hardware guide. This document is designed to allow you to work with your chosen hardware vendor to provide a server bill of materials that can support Vertica regardless of the vendor. As you read the document, you'll see we make several recommendations around the hardware, including things like CPU, memory, storage, and network. CPU choice is a balancing act. We typically like to see a core speed of around 3 gigahertz or more, with a good amount of cores per CPU. I say it's a balancing act because Intel CPUs tend to follow a pattern that the more cores you have, the lower the base CPU frequency is. So you'll want to be in the middle of that spectrum where the core speed is still high and you still have lots of cores. Memory is a little bit easier, but for the past few hardware reversions of motherboard designs, the number of memory buses per socket have increased to support the latest CPU models. So instead of having the old sweet spots of 128, 256, and 512 gigs of memory, you're now looking at 192, 384, and 768. The trick here is you want to evenly load the memory buses to achieve optimal memory access speeds. This can be different among vendor platforms, so have a conversation with your hardware provider because they're going to know best how to configure their own platforms. Storage in enterprise mode really hasn't changed much in the sense that more I/O performance is always going to be better. So utilize disk array technology that can offload I/O across multiple disks for the fastest access times. And speaking of fast access times, utilize NVMe drives if you can. Most major hardware vendors now offer array controllers that can support multiple NVMe drives in a RAID configuration. A good rule of thumb here is that your I/O subsystem should support at least 1,500 megabytes read-write speeds, with more always being better. Finally, network. 10 gig Ethernet is standard these days, but you need to remember that every node in your Vertica cluster needs to talk to every other node in the cluster. This is typically fine in small clusters that exist in a single rack. It's the rack-to-rack communication where things get more complex. If your network is configured such that all the nodes in each rack are connected to a top-of-rack switch, make sure that the pathways between the racks are wide enough to ensure that all the nodes in one rack can communicate with all the other nodes simultaneously. So I just said that network is the key to a shared nothing cluster model, and that's true. You should always be thinking about the communication pathways. Isolate that traffic if you can, and always make sure you maximize the size of your pipes. And while this seems a little obvious, talk to your hardware vendor about things like OS support and future OS support. This has become even more critical with RedHat's move to change the role of CentOS in the marketplace. What was once a binary compatible Linux version for Red Hat Enterprise Linux, CentOS has become the upstream testbed for RHEL. And honestly, you probably don't want to be running your production cluster on a testbed OS. So alternatives like Rocky or Alma Linux are now coming into play as replacements for CentOS. But does your hardware vendor actually have plans to officially support them? This is something you need to ask. Next, always be looking for bottlenecks, whether it's how you're loading your data, doing backups, or just your general day-to-day traffic. Things that create latency can magnify the performance degradation in Vertica, where the queries are typically running in sub-second times. Also be wary of single sources of failure and use redundancy when you can. If network switches can be configured to utilize multiple pathways between switches, do it. If your hardware supports redundant power supplies, utilize them. Always be on the lookout for that single thing that can take down a node or even your entire cluster. Use your vperf tools on a regular basis. Get a benchmark and check against the benchmark on normal intervals. Also, utilize the advisor reports. These are free, so you can use them to keep track of your clusters to ensure that changes are not being made at the cluster level without your knowledge. Consider this as preventive maintenance for your environment. And finally, because you can't protect against failures 100% of the time, do backups. There is simply no value you can place on a good recent backup when things go badly. While bare metal might be king, virtualizing Vertica to get the most out of your hardware and simplifying management is still a very popular item. We typically support most hypervisors. The caveat here is that we'll support you if your VM is running an OS that Vertica supports and is supported by the hypervisor. Additionally, and this is the tricky one, the hypervisor must provide a performant experience for the VM. It can't just work, it has to work well. On the right side, you can use the QR code to link to the Vertica documentation on virtualization. I'm not going to read everything on this slide, but I want to touch on three major issues that we typically see in customers that have virtualized their Vertica environment. One, over-provisioning or oversubscribing physical resources. By definition, virtualization allows you to oversubscribe the physical resources in a host machine. The end result is VMs will often have to wait to access these resources if they're being used by other VMs. This introduction of latency has a very negative impact on the query times and is the #1 no-no when virtualizing a Vertica cluster. Two, I/O performance. Since I/O latency can magnify into slower query times, using the fastest possible I/O in a virtual machine is highly recommended. And always test these options prior to deployments, keeping in mind that when you're using shared resources like a SAN, the SAN will probably run fine when tested against a single node, but will slow down when multiple VMs are accessing it simultaneously. If you're using a shared resource for storage, run the VIO-perf tool on all the VM nodes simultaneously to get a measure of how well your storage will actually perform. And three, spread traffic. By default, spread traffic in Vertica clusters uses UDP broadcast. However, in a lot of virtualized environment, UDP broadcast does not work the same way as it does in a physical world. When virtualizing Vertica, it's best to switch to the spread traffic to point rather than broadcast to ensure cluster stability. Once customers have started virtualizing their Vertica clusters, the next obvious step is to move into the public cloud. And here to talk a little about that is my good friend Sruthi.
Thank you, Chris. My name is Sruthi. Let's take a look at Vertica on AWS. AWS is the first cloud environment that Vertica started supporting Eon Mode as well as Enterprise Mode. We offer various deployment options for deploying Vertica on AWS. One can spin up a cluster on AWS within few minutes. Easiest way to spin up a Vertica cluster on AWS is via CloudFormation templates offered through AWS Marketplace. We offer two types of CFTs in the marketplace, namely Vertica by the hour and Vertica bring your own license with Amazon Linux or RedHat as the supported operating system. Herein, I have listed the QR code for the useful resources to get started with Vertica on AWS. Before deep diving into Vertica on AWS, let us get a brief picture of Eon architecture. Eon mode separates the computational process from the storage layer of your database. When running Vertica on Eon mode, you can store the data on cloud or on premises. Storing the data on cloud is more resilient and less prone to storage failures. Based on the growing needs of your business, you can scale your Eon Vertica cluster quickly. One can create subclusters and group the nodes based on the workload. Performance of the query depends on whether the data is present in the depot or S3 communal storage. Since compute and storage are decoupled, one can scale each of them independently. As mentioned earlier, data gets stored in communal storage. In this slide, you can see a cluster with 8 nodes, and each node is subscribing to 2 shards. For example, consider red shard. It has been subscribed by 4 nodes, that is 2 nodes in each subcluster. If one node in the ETL subcluster which got subscribed to red shard goes down, other node will serve any query pertaining to the red shard, ensuring high availability. One of the most striking features of Eon mode is subclusters. Users can divide the nodes into groups called subclusters based on their computational needs. For example, ETL requires more resources. So a DBA can create an ETL subcluster with many nodes. And in recent versions of Vertica, we started supporting subcluster level resource pools. To increase the efficiency, you can fine-tune your primary subclusters and allocate more resources for ETL and DDL tasks. This will not only help with the resource issues, but also helps in isolating the workload. Secondary subclusters are designed for dynamic scaling. They're optimized for running queries rather than DDL or data loading workloads. In Eon mode, Vertica has to fetch the data from the communal storage, and it can be a bit slow compared to accessing the data from the disk. So in order to improve the speed, Vertica maintains a local disk cache of the data called depot. So whenever you execute a query, Vertica initially checks whether the data is in the depot. If it is, then it finishes the query using the local copy of the data. If not, the node fetches the data from the communal storage and saves a copy in the depot. Herein listed are some of the configuration parameters which govern the depot usage, each having its own purpose. If depot space is not large enough, it is possible that a query will roll back with insufficient resources. In such scenarios, one can set use for depot. In such scenarios, one can set use depot for writes to 0. All these parameters can be either set at session level or database level. Now that we got a brief picture of Eon architecture, let's review what are the factors that you need to consider when installing Vertica on AWS. If you plan to install Vertica manually using existing deployed AWS resources, Vertica provides an AMI that you can use to install on AWS. However, users need to choose the right instance types, disk types, configure the network, security, and the list goes on. Let's review each of them in detail. The first is instance types. AWS offers numerous instance types, each optimized for a purpose. One needs to choose a right instance type based on the requirements of your application. Vertica recommends choosing instance types that support ephemeral instance storage or EBS volumes. However, it isn't mandatory to use the instances with EBS for Eon because data is stored on communal storage. However, for Vertica in enterprise mode, it is recommended to use EBS because the data is stored on the local disk. Herein we listed few recommended instance types for Vertica in Eon and enterprise. Storage optimized instances are most recommended for Vertica on Eon because they provide high IOPS at a low cost. For example, i3-4x large is most economical and can be used for primary subcluster. For Vertica on Enterprise, we recommend using R4 instances because they are optimized for memory intensive applications and support enhanced networking. Vertica recommends configuring Gateway S3 endpoint for your VPC. A Gateway S3 endpoint is a target for a route in the route table to connect VPC resources to S3. In this picture, you can see that instance in subnet 2 can access S3 through the gateway endpoint. This is useful for Vertica in Eon mode because it allows egress traffic only to S3 service, which makes it more secure and it is free of cost. Vertica recommends creating placement groups because it groups EC2 instances close together inside an availability zone and provides low network latency, high network throughput, or both. We recommend choosing instance types that support enhanced networking because it provides high performance networking capabilities. Enhanced networking provides higher bandwidth, higher packet per second performance, and consistently lower inter-instance latencies, and again, it's free of cost. When running Vertica on cloud, users must set control mode as point to point because cloud doesn't support broadcast for spread. Last but not the least, we recommend using instance profiles as they are more secure and easier to maintain. If you can, it's always better to use the CFTs provided by Vertica in Marketplace because we try to spin up a Vertica cluster quickly with the minimal configuration as listed here. With that, I would like to hand over to Chris to cover GCP Azure.
Thank you, Shruthi. Well, AWS gets the majority of the recognition from Vertica in the cloud space, and rightfully so, given our long history with them. Google Cloud Platform has become a very popular platform for running Vertica in Eon mode. GCP is actually the second cloud to see support for Vertica EON mode in general availability back in the Vertica 10 release. What is most interesting about that is that shortly after that release of EON mode in GCP, we also started offering a by-the-hour licensing option, allowing customers to quickly spin up an Eon mode cluster with no licensing limitations and only pay for what actual usage time they had on the cluster. The licensing model for this followed the similar one that was already being offered in the AWS space. On the right here, you can use the QR code to link to the Vertica offers in the Google Cloud Marketplace. And while we've done a lot of work to automate the solutions coming out of the marketplace for GCP, we also recognize the simple fact that for a lot of you, building your own cluster manually is the only option to meet company or IT-specific requirements. So with that in mind, let's talk about the things that you need to understand in GCP to get that done. Does this slide look familiar? Yep, it's a duplicate slide from the AWS section. It's merely an acknowledgement of all the things that you need to consider when running Vertica in the cloud. In Vertica, the choice of the operational mode will dictate some of the choices that you'll need to make in the infrastructure, particularly around storage. And just like an on-prem solution, you'll need to understand the disk and network capacities to get the most out of your cluster. One of the most attractive things about GCP is the pricing. It tends to run a little less than the others, but it does translate into less choices and less options. If nothing else, the thing I want you to take away from the slide is that VMs in GCP are running on top of hardware that has hyper-threading enabled, and that a vCPU doesn't actually equate to a core, but rather a processing thread. This becomes particularly important if you're moving from an on-prem environment into the cloud, because a physical Vertica node with 32 cores is not the same thing as a VM with 32 vCPUs. In fact, 32 vCPUs, you're really only getting 16 cores. GCP offers a handful of VM types categorized by letter, but for us, most of these don't make great choices for Vertica nodes. The N series, however, does offer a good core to memory ratio, especially when you're looking at the high mem variants. Also keep in mind, performance of I/O, such as network and disk, are partially dependent on the VM size. So customers in the GCP space should be focusing on the 32 vCPU VMs and above for their Vertica nodes. Disk options in GCP can be broken down into two basic types: persistent disks and local disks, which are ephemeral. Persistent disks come in two forms, standard and SSD. For Vertica and Eon mode, we recommend that customers use a persistent SSD for the catalog, while either local SSD or persistent SSD are both acceptable for depot and temp space. A couple of things to think about though. Persistent disks are provisioned as a single device with a settable size. Local disks are provisioned as multiple devices with a fixed size, requiring the use of software rating to create a single storage device. So while a local SSD can provide much more throughput, you're actually using CPU resources to maintain the RAID set. Also, VMs that are created with local SSDs can't be stopped and started like normal VMs. Your only choice is to either leave it running or to decommission that VM, which basically means you're destroying it. So when it's time to use that particular cluster or subcluster, you're reviving it, not simply restarting it. And this can take a little bit longer time. Persistent disks offer redundancy either in the zone they exist or within the region. If you select regional, the disk is replicated across multiple zones in the region for redundancy. But this does have an effect on the performance of the VM, which is why we recommend you choose zonal redundancy when using persistent disks. Also remember, in the cloud space, all I/O is network I/O, as persistent disks are basically block storage devices that are attached to the VM via the network. This means disk actions can and will slow down network traffic. On the right-hand side of the screen, you can use the QR link to read the breakdown of the current disk speeds and limitations within the GCP space. And finally, storage bucket access in GCP is based on GCP's interoperability mode, which means that it's compliant with the S3 API. In interoperability mode, access to the bucket is granted via a key pair that GCP refers to as the HMAC keys. HMAC keys can be generated for individual users or for service accounts. We recommend that users choose a service account to ensure that the keys are not tied to a single employee. Lastly, networking and some things to consider in your Vertica cluster. Pick a region of deployment that's physically close to you. Even if you're connecting to the GCP network from a corporate LAN as opposed to across the internet, the further the packets have to travel, the longer it's going to take. Also, GCP, like most clouds, doesn't support UDP broadcast traffic in their virtual networking. So you have to use the point-to-point flag for spread when configuring your cluster. And since the network cap on VMs in GCP is set at 32 gigabits per VM, maximize your network egress throughput and don't use VMs less than 16 vCPUs for Vertica nodes. On the right, this QR code links to a great blog post from Google that described their best practices for maximizing network performance. Last, but by far not the least, there's the Microsoft Azure environment. Offering a much different experience over its rivals, the Azure environment has been growing steadily for some time, and Vertica has been available in Azure in enterprise mode for several years. But in Vertica 10.1.1, we released native access to the Azure storage accounts using the AZB source. And with the release of Vertica 11, Eon mode has been in general availability in Azure. You can use the QR code on the right here to see the listings currently available for Vertica solutions in the Azure Marketplace. As I just mentioned, Vertica offers native access to the Azure Blob storage. And in this slide, I'm showing you the format for usage. While this is similar to the S3 or the GS formats for accessing Object Store, you'll notice that in Azure, we need to reference the storage account, not just the container or the bucket as it's called in S3. This is because of a fundamental difference between object storage in Azure as opposed to the other clouds. In AWS and GCP, object storage is a service where you can create buckets for holding your files. In Azure, storage accounts are resources that get deployed along other infrastructure as service resources. You can have multiple storage accounts, and each storage account can have multiple containers. This basically means we have to identify which storage account we're accessing along with the container and the path to where the data resides. Access to the storage accounts is granted in two ways. You can use the traditional method of providing keys for access to the container, or you can use what Azure calls managed identities. A managed identity is an identity resource that's associated with a different resource, like a virtual machine, and granted a specific access role and scope. For example, you can create a managed identity, give it a Blob storage contributor role, scope that role to a specific storage account, and then assign the managed identity to a VM that will access the storage account. This is exactly what we do in the Eon Mode solution from the Marketplace. The downside to managed identities is the individual setting the role assignment needs to have either administrator or owner level access to the Azure subscription. This can provide difficult in the case of larger organizations that use Azure and maintain a tight level of subscription security. In those cases, you can see that feeding the storage access keys via Vertica in an alter session command is straightforward and an easy approach. So here's the slide again, and in Azure, like the other clouds, there are a lot of similarities for running Vertica. Now that we're supporting Eon Mode in Azure, things like node choice become a little different than they have in the past. You're still going to need to get the local storage performance right, but now there's more options. The other major key is making sure that you're getting the appropriate networking speeds for your cluster. Overall, Azure is a great platform for Vertica with performance and pricing on par with AWS. But keep in mind, because Azure uses Hyper-V as its hypervisor, newer versions of the Linux operating systems like RHEL run better than the older ones do in this environment. First thing first, just like GCP and AWS, in Azure, VMs are hosted on hardware that has hyper-threading enabled. And because of the way Hyper-V handles this, it actually exposes this directly to the VMs. If you look at the CPU information on the VMs, you'll see how it groups the vCPUs by core and by thread. This will show up when you run tools like VIO-perf, and they will detect hyper-threading and report the real number of cores in the VM. Azure offers a lot of VM types, and it's adding new types all the time. But for us, we see two VM types that make the most sense for Vertica. For customers that are looking to run production workloads in Azure, the ES v4 and v5 and the EDS v4 v5 series are the two main recommendations. While they're the same in the CPU and memory ratios and I/O throughput, the EDS v4 v5 series can offer an advantage in Eon mode. The EDS series VMs come with a temp SSD storage device, which is very fast and can be used for temp or depot space. These drives are ephemeral, which means that when you turn off the VM, you'll lose any data that exists there, so only use them for temp or depot. If you're just deploying a sandbox environment, the DS-V4 series is a very suitable choice to reduce the overall cloud expenditures, as the nodes are less expensive, but they also have less memory and less I/O capacity. VM block storage in Azure is provided by a grouping of 4 different types of disks, all offering different levels of performance. Introduced most recently, the UltraDisk option is the highest performing disk type for VMs in Azure. It was designed for database workloads where high throughput and low latency are very desirable. However, the UltraDisk type is still not available in all regions yet, and it is quite expensive. The premium SSD option, which has been around for a while, is widely available and can offer nice performance and higher capacities with a much better price point than the UltraDisk option. Remember, just like other clouds, the I/O throughput you'll get on the VMs is dictated by not only the size and type of the disk, but also by the size and type of the VM. A good rule of thumb in Azure, VM types with an S are optimized to have better throughput rates, and larger VMs mean more I/O throughput. Disks comes in multiple different sizes, and each size offers different levels of maximum performance. Your options to maximize I/O are either to start with a single large disk or multiple smaller ones striped together using software rating technology like MDADM. In testing, we found that multiple disks in a RAID 0 outperform larger single disks, but the trade-off is that you're using CPU cycles on the VM to maintain the RAID set. One nice thing about all the managed disks in Azure, they're all encrypted by default at the server side, so there's nothing you need to do to enable that. Networking in Azure comes in two different flavors, standard and accelerated. In standard networking, the entire network stack is abstracted and virtualized. This works very well, however, there are performance limitations. Standard networking tends to top out around 4 gigabits per second. Accelerated networking in Azure is based on single root I/O virtualization of the Mellanox adapter. This is basically the VM talking directly to the physical network card in the host hardware and has produced node-to-node network speeds of up to 20 gigabits per second. Keep in mind that not all VM types and operating systems support accelerated networking. And just like disk throughput, network throughput is also going to be based on the VM type and size. So what do you need to think about for networking in your Azure space? Again, stay close to home. Pick regions that are geographically close to your location. Yes, the backbones between regions are fast, but the more hops your packets have to make, the longer it takes. Azure offers two types of groupings for VMs, availability sets and availability zones. Availability zones offer good redundancy across multiple zones, but this tends to increase the node-to-node latency in the network, so we recommend avoiding this. Availability sets, on the other hand, keep all the VMs grouped together within a single zone while making sure that no two VMs run on the same host hardware, which is important to reduce any downtime due to a host failure. Just like other clouds, UDP broadcast is not supported, so you have to use the point-to-point flag to ensure that spread is working properly. And finally, a word about spread timeout in Microsoft. Microsoft has implemented its own update process as rolling updates in their environments. What this looks like to a VM running on top of hardware that's receiving an update can be thought of as the VM being paused. This becomes problematic when pausing of the VM exceeds 8 seconds, as non-paused members of the cluster will think that the paused VM is down. Considering adjusting the spread timeout for clusters in Azure to 30 seconds to help avoid being dropped from your cluster during a maintenance event. If you're deploying a large cluster in Azure, use the large cluster mode to scale it more effectively. And pick VM types and operating systems that support accelerated networking. The difference in node-to-node and node-to-storage account speeds can be dramatic, and it's free to use. So after designing an operational mode for Vertica to allow it to take advantage of the cost savings in the clouds, what do? Well, we bring it full circle, of course. Vertica, that started in the data center and enterprise mode, moved into the virtualization space, and then jumped into the public cloud, and now is coming back home as Eon Mode On Premise. So how did that happen? Well, after the release of Eon Mode in the public clouds, companies, such as yourselves, started adopting object storage technology, and not just for Vertica, but for many other applications as well. And in fact, it had become so popular that many companies started exploring the idea of bringing S3 compatible storage back into their physical data centers to support object storage in either a hybrid cloud or a complete on-premise solution. And because this has become such a popular idea, many storage companies are now supporting the S3 API on many of their physical storage solutions. For Vertica, on-premise Eon Mode was first devised as an interesting science project between one of our customers and our development team. And since that time, it's been gaining serious traction over the last several releases. So much so that we started getting inundated with requests to support object store solutions from many different storage vendors. On the right, you can use the QR code to link to the Vertica documentation that describes deploying Eon Mode using an on-premise communal storage device. And here, you'll see which partners we've aligned with so far. These are all the current vendors that have worked with our partner engineering team to validate their solutions running Eon Mode on premise. And while we cannot talk about the vendors currently in process, or the ones that have already lined up to start it, and there are a lot, the point is that the solutions for on-premise Vertica Eon Mode are growing at a fast rate as customers are starting to understand the value of Eon Mode when running outside the cloud environment. But how do you validate a backend object store for Vertica? Eon Mode was originally written to support the S3 APIs as created by Amazon. And when talking to storage vendors about their particular S3 compatible solutions, the one thing that we hear over and over is, we are 100% S3 API compliant. However, in some cases, this statement has been a bit misleading. What's missing is that while the API calls they support are 100% compliant, they don't necessarily support 100% of all the S3 API calls. It quickly became obvious that what we needed to do was to devise a validation process to ensure a vendor's S3 compatible product not only worked correctly with Vertica, but also so that we could understand the ins and outs of sizing and scaling it and the limitations of the product. Let me take a minute to let that sink in, because this is a major point for deploying Eon Mode On Premise. In AWS, S3 has very few limits. You can grow your bucket without having to concern yourself about how it's being supported on the back end. You could increase the traffic to the bucket without having to be concerned with overwhelming your network infrastructure. All of this was handled by AWS and done seamlessly in the background. But when you move to this on-premise, guess who's responsible for it now? In order to be successful on-premise, the back-end communal storage needs to be able to scale effectively, both from a size and performance standpoint. And while the storage array will do the heavy lifting, part of that performance is going to be the network segments that connect Vertica nodes to the storage array. This is why we have a validation process for on-premise S3 storage solutions, because before you deploy something, we'd like to make sure it works. We use several different tools, including a set of tests that use a real vertical cluster that's designed to push the limits of the communal storage. Storage partners must complete these successfully before we engage with any sales motion for an Eon on-premise deployment with their solution. In fact, we even ask our vendors that have recently passed through this validation to move forward for the first few sales with us hand in hand to make sure that customers are getting the best possible experience. What do you need to keep in mind when deploying Eon Mode on-premise? Well, like I just said, when you move on-premise, you're now responsible for all aspects of the performance and scalability of not just the cluster nodes, but the back-end communal storage and all the networking throughput required for the cluster nodes to the storage array. Network performance is going to be a crucial aspect of this, and you're going to want to isolate the network pathways between clusters and the storage array as much as possible, and provide the fastest and widest links that you can. Yes, Eon Mode relies on a local depot for the majority of the work, but the final mile between the cluster nodes and the communal storage is going to be one of the most obvious bottlenecks in any Eon Mode solution. Also, do your homework on the storage array you plan to use. Understand how it will scale from both a scale up and scale out perspective. Don't plan for the workload you have today. Plan for the workload you plan to have in 12 or 18 or 24 months' time. This will alleviate issues in the short term while allowing you to focus on the day-to-day business. And finally, work directly with your storage vendor to help build out not only the hardware recommendation, but your long-term plans for growth. Each of the storage vendors that have passed through the validation process have different methodologies for scaling. Understanding those today will make it easier to implement them when the time comes. And while the S3 object store gets a lot of attention, it's not the only object store that Eon Mode can run against. Sruthi, would you like to talk a little bit about running Eon Mode against HDFS?
Sure, Chris. Now let's take a look at Vertica EON on HDFS. It operates the same way as Vertica on cloud or on premises. However, HDFS is used as communal storage. HDFS is a distributed file system which generally provides high durability at a low cost. Vertica has been supporting HDFS as a storage location from many years, and you can also access HDFS data in place using external tables. To use HDFS as communal storage location, for Eon Mode database, one must configure their Hadoop cluster with WebHDFS. If HDFS has high availability name node support, we will use name service ID as the authority in our WebHDFS URIs. When a user tries to load the data into Vertica, we are first going to connect to HDFS name node. Name node returns the URI for the data node, and we upload the data in chunks to HDFS data node which is returned by the name node. Chunk size is generally HDFS block size. If you want to make your communication with HDFS more secure, you can enable Kerberos authentication. And we started supporting MTLS as well in the recent versions. Let's review some of the common questions raised when we deploy Eon cluster using HDFS as communal storage. Since the data is uploaded via chunks to communal storage, the typical question which arises is there a way to control the chunk size? Yes, there is a way, and one can modify the block size in HDFS and change the Hadoop FS block size bytes parameter in Vertica. Another frequently raised question is where does the data get stored when the initial query to HDFS fails? It is stored in the memory buffer, and web HDFS upload buffer size KB is the parameter which controls the buffer size. Last but not the least, fault tolerance is governed by DFS.replication parameter of HDFS with default value being 3. Here is the QR code which contains the useful resources for getting started with Vertica EON on HDFS. Now let's take a look at containerized Vertica. Containerized Vertica is pretty new. Before diving deep into containerized Vertica, let's take a minute and understand where Kubernetes came from. It is Google who created a platform named Kubernetes and donated it to Cloud Native Computing Foundation, which is CNCF. Kubernetes operates at a higher level, providing orchestration services such as self-healing, scaling, and so on. Why do we need containers, or rather, what is a container? So far, our applications have been running on physical servers or in the virtual machines. More in the virtual machines once the virtualization buzz started. Currently, we are in the cloud era, and one can think of containers as the next iteration as how applications are packaged. They are completely isolated environments, as in they have their own processes, services, their own network interfaces, own mount points, just like VMs, except that they share the same OS kernel, which makes them lightweight compared to VMs. Now let's review some of the advantages of using containers. Using containers as a unit of deployment is very useful for agile development. They are generally sized in megabytes or less, making them very lightweight. As the demand for a microservice grows or falls, the number of the containerized instances can be automatically grown or reduced with minimal overhead. This will help in reducing the costs at a granular level. It is cloud native because it has the capabilities of self-healing, rolling updates just like cloud. Without any further delay, let's get started with Vertica in Kubernetes. Here is the architecture of Vertica in K8s. The nodes are called pods here. The Vertica CRD extends the Kubernetes API so that you can create custom resources which deploys a Eon Mode database as a stateful set. In addition, Vertica provides DB operator. It's a custom controller that maintains the desired state of your CR and automates the lifecycle tasks. The result is a self-healing, highly available, and a scalable Eon Mode database, which requires minimal manual intervention. It's extremely easy to get started with Vertica in K8s. You can deploy to your on-prem environment or in the cloud with managed service or hybrid environment. In this example, a 3-node database is created within a K8s cluster where each Vertica pod shown here contains a container that runs Vertica process. And each node has a local persistent storage that acts as a depot for each node to process and distribute the hot data from the communal storage. Finally, within each subcluster, you can define a service type that would allow client access. For example, to connect to Vertica and run a query against Vertica from DB Visualizer or many other tools. Herein is the list of platforms or communal storage options we support. We support running Vertica on managed K8 service provided by all three major cloud vendors. Apart from the ones listed on the screen, there are many which are currently being tested under the hood, which will be available soon, providing customers with wide variety of deployment options. Now let's review about VerticaDB Operator. It's a namespaced custom controller that maintains the state of the custom objects and automates the administrative tasks. It basically watches the objects and compares their current state to the desired state declared in the custom resource. When they don't match, it works on restoring the objects to the desired state. In addition to state maintenance, it performs all the tasks listed here, such as installing Vertica, restarting a down node, and so on. Now that we got a picture of what VerticaDB Operator does, let's review its deployment options. First step is to set up a K8s cluster on a supported platform. If it is on cloud, please use the recommendations provided by Chris earlier to choose the best instance types. Before installing the VerticaDB Helm chart, you must configure TLS for the admission controller. Admission controller is mainly used for validating the state changes in the CR. You can either use custom certs or install Cert Manager, which will take care of everything. Currently, we provide two deployment options. It's via Helm chart and Operator, which can be deployed from Operator Hub. The typical question which arises is, can I set up a VerticaDB using one deployment option and then later use other deployment option to upgrade? Well, the answer is no. Each install option has its own workflow that is incompatible with the other option. Now let's review some of the striking features of containerized Vertica. We support all the features listed here on the slide, but let me walk you through the top 3 features that I would love to use. Sidecar containers are the containers that are needed to run alongside of the main container and acts as a helper for the main container. Vertica provides a sidecar container called vlogger, which sends the contents of Vertica log to the standard output on the host node for log aggregation. Another exciting feature is air-gapped clusters, which are supported starting 11.1.1. As a security feature, you can deploy the operator in an air-gapped cluster, which is a cluster that is disconnected from other networks. In an air-gapped cluster, you would not be able to deploy it from the Docker Hub and would rather rely on private registry, and those details are parsed in the CR. We use role-based access control for authorization. Another exciting feature that I would love to use is hybrid Kubernetes cluster. It's a way to combine your on-prem cluster with a subcluster running in K8s. This is a cool feature because with K8s, you can quickly spin up a secondary subcluster and run ad hoc queries. You can also use this to experiment Vertica on Kubernetes without migrating your primary subcluster into K8s. However, hybrid Kubernetes cluster require a tool that enables border gateway protocol so that the pods are accessible to your on-premises subcluster for external communication. There are many interesting features under the work and which will be released soon. Now let's get a quick picture of how to set up Vertica database on K8s. You can either use a managed or an open source K8s cluster. Once you have your K8s cluster ready, deploy a volume provisioner which can create persistent volumes as needed. Use one of the deployment paths mentioned earlier and install the VerticaDB operator. Next step is to create the secrets for storing sensitive information such as super user password, the license key, access keys for communal storage, which can be defined in your CR. Once you have your YAML file ready, you would just deploy it using kubectl apply command. Herein, I have included the QR code, which contains the useful resources to get started with Vertica on K8s. On the slide shows a sample CR, which creates a 3-node database with 6 shards. Most of the fields are self-explanatory. I would say review the documentation to get a detailed explanation of all the custom resource parameters. Now let's take a look at upgrading Vertica in K8s. You can upgrade Vertica version without taking your cluster offline using kubectl patch. It's a 3-step process. The first step is to set the upgrade policy custom resource parameter in your CR. Default option is auto. The operator selects either offline or online depending upon your cluster configuration. With online upgrade, data is available only in read-only mode. Online upgrades require more than one subcluster so that the operator can reroute the client traffic to the secondary subcluster while it is being upgraded. If you just have one primary subcluster, then you can reroute the client traffic to a temporary subcluster, which is auto-created. And this temporary secondary subcluster feature is available starting 11.10. Once the route option is chosen, one can upgrade the cluster using kubectl patch with the desired image name, which takes care of everything, including upgrading all the Vertica subclusters one by one and restarting them in order. Last but not the least, let's review about some of the unique aspects pertaining to Vertica on OpenShift. We support running Vertica on OpenShift 4.8 and above. Administrators can use the security context constraints to control the permissions for pods. OpenShift requires each deployment to use a SEC, and using that, one can restrict the namespace access. Vertica on K8s supports 2 SECs. The first one is the privileged SEC, the most restrictive and the default SEC. And the second one is any UID extra custom SEC, which is less restrictive SEC. We support installing the DB operator in multiple OpenShift namespaces, and it can be achieved by creating an operator group object and subscription object file to subscribe a namespace to an operator. After you have installed your DB operator and added a supported SEC to your Vertica service account, you can deploy Vertica on OpenShift using the same steps which I walked through earlier. With that, I would like to conclude the session. Thank you, Vertica, for providing me an opportunity to present at Unify, and thank you everyone for your time. I hope you find it useful.